Hello and welcome to today's webinar, Drive SOC Efficiency with Network Data and ML. At the end of today's webinar, we will have a Q&A session. So if you have any questions for our presenters, please enter them into the questions tab. And now I'd like to introduce our first presenter, James Schweitzer.
Hi, thank you very much, Ed. It's my pleasure to talk to everyone today. Today, as we talk about SOC efficiency, we're actually going to be partnering with Elastic. And I want to take a moment and introduce our presenters. Matteo is a security specialist at Elastic. He's going to spend time talking a lot about ML and the capabilities of Elastic Security. Richard Harlan is an SE in the TOLA region for Corelight. He's going to spend some time talking about the specific Corelight integrations with Elastic. And myself, I'm James. I lead the SEs for the East and Federal within Corelight. So let's get right on down to the information for everybody. I'll quickly go over the agenda. Really what we want to talk about is a data problem. And we'll summarize this. Everyone is very well aware of some of the challenges you have with data. What Corelight does is a solution that is different on how to address that problem. From there, we'll introduce Elastic Security. And Elastic Security is the new solution for the SAM that can combine that with endpoint security for their use case. And we have a few examples we're going to talk about leveraging Corelight data with Elastic Security and some automated detections. And then we'll have time for Q&A if anyone has Q&A afterwards. But before we get started with that, I think it's important to mention that next week, we have a virtual Zeek week. You can go down and visit zeek.org. With this, the first day is training. Day 2 is threat hunting is going to take place. And day 3 is a chance for really dev discussions and roadmap discussions that are going to take place. But it's really a great time. Be sure to register. It's going to be very informative to talk about the discussions of what's the state of the possible with open source Zeek. Similarly, unfortunately, overlapping is Elasticon, but it's also going to be recorded. You can go down and you can see at the bottom of the slide is their registration. So go ahead and register. Elasticon actually has Trevor Noah and Megan Rapinoe are going to be some of the guest speakers. It looks like it's going to be an action-packed agenda with customer stories as well as some one-on-one opportunities for networking. And with that, now let's get right into the data problem. Networks can generate hundreds of thousands to millions of packets daily. And there can be a whole lot of value with that information, but there also can be information that is really a lot less value. Think maybe DNS pointer records, for example. And really it's what I'm trying to get with this graphic. Which would you rather swim in, drink from, Crater Lake or the Pacific trash dump with a lot of, garbage? Or, this could also be, if you wanted to say, if you're not familiar, Lake Karachi. It's in the Ukraine, and it's the most polluted open air place on Earth. Think about it from a radiological point of view. What Corelight wants to do is we want to provide you the best data to ingest into Elastic Security for your team to conduct an investigation. We also want to help you. We're going to talk about several tools that we have to allow you to ensure that it is the best data and it's only the content that you need in order to conduct the investigation. But by doing that, I think it's really important to recognize that Corelight is really more than a data format. There's an open source community that has been really evolving and working with this data for over 20 years. Having this 20-year evolution with developers and incident responders working together, they have made the data better. They've really kind of altered over time the structure of the data because it's not just, let's face it, logs are created because someone is troubleshooting something. They don't really think about its operational use. Throughout the 20-year history of Zeek and Corelight, what you have is these logs have evolved to support operations. They support people who want to conduct investigations. And part of that is really extensibility. And it's the logs, you can add new fields. If there's a value in the packet that you want to add to the log, you have the capability that you can extend the Corelight data to include that. If there's a new protocol that you want to parse, you can either use the current bin pack or really what's coming, and it's an alpha release, is the spicy protocol. You can do that so that you have the opportunity as an end user or an enterprise to really be on the leading edge. You're not dependent upon a corporation to drive what content you have within your SIEM to conduct investigations. From that, we really think that the Corelight, it's a platform. So in addition to the logs, it's really writing applications or scripts or packages, things that consume events. You can do this so that you can share with others within your enterprise or within the broader community of either Corelight customers or on the open source. There are several examples of this that have been written to as packages to fingerprint a TLS connection. So then you can do data stacking to see what you recognize, to actually look for the eternal suite of exploits that were released to detect that. Really, and I think it's important for people to recognize all of the capabilities that Corelight has as a platform and why it's not really a format. And I think a great analogy that was on a Corelight blog is you could talk about the Taj Mahal as a building with 120 rooms, but would it really do justice to talk about the Taj Mahal like that? And I think that's a great analogy to think about what Corelight can do. It's more than just a log. It's more than just a format. It's really supporting your security operations and your broader security ecosystem, with data. But now we've talked a lot about that. Let's get in and talk about the Corelight solution itself. Corelight solutions span, if you think traditional physical hardware that you would see in a data center that you see on the right side, they're all 1 RU sizes. But it's really as we move to the left when we start talking about either our software sensor, which is for container or a native OS deployment, our virtual sensor or cloud sensors. So you see for the cloud, AWS and Azure for our cloud sensor, our software sensor actually is able to deploy on GCP. What Corelight does with our solutions is we provide you the same platform to deploy no matter it's a physical deployment, a virtual deployment, or a cloud-based deployment. All of these Corelight solutions can be managed from our Fleet Manager. And as we went through the development of the Fleet Manager, we decided to make it a virtual machine so that it would be easy to deploy within your enterprise, and you could deploy that in the cloud, if you choose. But now that we know what Corelight offers to kind of get the data, how do we work with other SOC solutions? Corelight fits firmly in the newly defined network detection and response category from Gartner. And with this, we think what we're doing is, for the long time, throughout the history of open source Zeek and Corelight, we provided rich curated metadata. What's happening on the wire? We're curating and providing you that information that you can use to respond to an event on your network. As a result of that, you can identify anomalous behaviors, suspicious activities that are taking place. Just recently, Corelight integrated Suricata into our solutions. And I think it's important to mention that it's an integration, and we're the first to do this. Many folks in the open source, as well as some commercial companies, have installed the two that run side by side. What Corelight has done is they've combined the contents of the Corelight, the con log, with the Suricata Eve log. By putting both of pieces of information into one, they're making it easier for folks who are analyzing the data to quickly assess if an event was a true positive or a false positive. Was that event an incident? Corelight solutions also can perform file extraction, so we can carve off files so that you can use that within your existing data pipeline, whether you use Cuckoo, Silence, depending on what solution you have to perform a dynamic malware analysis. Corelight can extract those files to extend into your existing pipeline. And lastly, oftentimes people want to fall back on PCAP. Corelight created 2 years ago something that's called Community ID. Community ID, think of it as it's a foreign key to pivot from one data type to another. And so there's been broad adoption, for example, with Community ID for Moloch in the open source, as well as most recently Wireshark has announced its support. So to provide you the opportunity where you can pivot from Corelight data using the Community ID to another data source, another form of analysis. So Corelight is here to complement your existing SOC solutions. But I've done a lot of time talking about Corelight and open source Zeek. What's the difference? Why should I be interested in Corelight when I just have something that I can use with the open source? We'll start off with really scale. And oftentimes when people talk about scale, they really want to focus on one variable, throughput. And I would like to see, there's the old adage, that speed kills, but handling is something that can tame speed. And that's something that Corelight has worked through. And the first graphic that we brought up, if you look at the top graph, we're showing that we have one of our sensors that's processing anywhere from 15 to 23 to 25 gigabits per second of traffic. And what you'll see on the bottom is the red, and that's showing the number of drops. So you can see consistently the sensor's hovering around 0. Every now and then it goes up to a small amount of drops. And that's going to vary within your network. We like to always claim that there's 0% packet loss, but sometimes there's going to be some. You also will see active flows as well as the data rates per port. But that, again, that's just addressing the speed. I want to talk about handling. What can we do to help you with this so you can process better, and what are differentiators? When you send the data and export the data for analytics within your environment, we have what we call a global filter. So you can filter traffic to say, I want to send no DNS pointer records to one or more of these exporters. So you'll see I can send data to Splunk and Kafka and syslog and Elastic and even JSON all concurrently. And we can do that without a performance hit based on how Corelight is architected. But that's not the only way that we allow you to tame. It's really also, you can have a global filter, but then you can also have a locally relevant filter. And sorry, this is a little small on the screen for everyone. But what we can have is we can actually exclude individual logs that you might not be interested in sending out to that SIM, and also a locally relevant log filter. So what Corelight does, again, is we want to simplify the ability to filter data that's going into your SIM, because we don't want you to have a trash dump or a dumpster full, of data that's not going to help you either conduct an investigation or troubleshoot a network problem within your environment. But this only tells part of the story. I think content is really important. Corelight, as they've gone through, and Zeek, doesn't use the concept of client and server when they're addressing a connection. What was done is, you can see what we have on the screen is it's identifier, the originating host, and identifying the responding host. And they did this because oftentimes the concept of client and server really depends on your perspective. And to simplify it and be more exact, it went through kind of the orig_h and res_h, and then you have the originating port and the responding port. The challenge with that is that nomenclature is not really very broadly accepted. And so now you have a problem. You want to use that with other organizations, folks not recognizing, that data. So now your queries are that much more difficult. What Corelight has done is we actually have a pipeline to simplify that and move those into kind of more common names: source address, destination address, source port, responding port. And we'll talk a little bit about that as we move through with my colleague, Richard. Lastly, we'll talk about our encrypted traffic collection. And there are really two aspects of this that I'll pass off to Richard. We're going to talk about, kind of good hygiene that's going to take place, as well as kind of detecting encryption. And I'll leave it to Richard to kind of go through that. With that, I'll pass it off to you.
Thank you, James. So with the encrypted traffic collections, we're really looking at how do I get the most data from encrypted traffic without necessarily having to decrypt the traffic itself. So what we're seeing stuff is like how many, what kind of certs are being used, validation, weak keys, new and expiring. I don't know about you guys, but I remember back in the past having to work for a large corporation with multiple websites, and I think in this case it was like 3 Class C networks we had to search, and we had a Perl script that would just constantly pull these networks and look for certs out to expire. How much easier would it be is if we got those alerts right away, because the data was going right into the SIM, we would get the alerts, be done with it, wouldn't have to maintain the script, wouldn't have to constantly worry that if the script didn't run, we might have an expired cert. So now we're basically telling you is as the request happens, we are checking to see if the cert's going to expire. From a security standpoint, now I can also start looking at what certs are new in the network. Do I have something that's just popped up? That's interesting. The other thing is like weak keys. So if I see all of a sudden that I have a set of browsers that only support a certain type of encryption, and that encryption is being sunsetted, I can very easily go through there and find all these people and then update them. So we go. The other things that we can get with the encrypted traffic collections are encryption detections. So what we're seeing there is that usually when you have an SSL session, you have an asynchronous key exchange and then a bulk encryption. And then that asynchronous key exchange, what it's doing is they're determining how they're going to share the data. So they have to have a shared key. So that's setting up to do the shared key. But now if we see someone jump right from a startup to bulk encryption, we're able to detect that they have a pre-shared key. We're not convicting this, but we're saying this is something to look at because a lot of malware does use pre-shared keys as a way to get around stuff. The other thing we can do is if you have a policy where you're letting through encrypted connections or you're not necessarily doing decryption analysis, what if someone's trying to pass unencrypted packets through there? It could be just a mistake. It could be something. It could be anything. So we're able to detect is that even though the stream is on an encrypted port, we have unencrypted data passing through it. So it's a very interesting alert, highly done with hygiene. I mean, it could just be, like I said, an unencrypted mistake. So this all pops into different alerts that you can do. Next slide, please. Now, the other thing is like what James talked about, we have all these packages so that when the curveball came out, within a few hours, we had a Zeek package out there. And a lot of companies did this, but here's the thing that really sets Zeek and Corelight apart is I know from the day I get that package forward if I had into that curveball. But the question really comes back to is curveball's been around for a while. How many people knew about it? And was I ever exposed beforehand? So I want to go back in the past. So I could do this through TCP dumps if I have the right data and I want to search through everything. But how far back can you go? With Corelight, I could go back as far as I need to. As long as I have the data, I can run this command down below and actually search to see in the past. If I have 6 months of data, I could search through it with Elastic and use this query to say, hey, I had a potential curveball incident 3 months ago and figure out what's going on. So this is the things that Corelight gives you is the ability to detect in the future and go back into the past as long as I'm maintaining the data.
Excellent, excellent. Thank you very much. Well, with that, I'll transition over to Matteo. If he wants to start talking about how can Elastic Security use the data that Corelight provides.
Thank you. Let me just a second. I'm gonna share my screen. All right, thank you. Yeah, introducing Elastic Security. I mentioned earlier, I joined Elastic about 2.5 years ago, and many of you may know Elastic as the company behind the popular ELK stack. That stands for Elasticsearch, Logstash, and Kibana, or the Elastic Stack. And that's the case. So we are our CEO and founder is the developer that wrote Elasticsearch at the very beginning of Elastic. And Elastic since then has been used for many different use cases. And when I joined Elastic, we didn't have a solution for security, yet Elastic was used in many security use cases, going from threat hunting to augment an existing SAM deployment. Elasticsearch is as the name says, is optimized for search. It's a search and analytics search engine that can scale horizontally with really no limits that allows you to ingest any types of data. And what organizations and users had to do years ago is really to build a lot of content in order to use Elastic. They had to build their own integrations. We didn't have a common schema back then, for example, and we didn't have specific applications for the SAM and endpoint security use cases. So what Elastic decided to do about 2 years ago is to build a security solution on the top of the stack that all of you probably already know, or you may have seen Kibana. It's very, very, very popular and commonly used. So when we started working on this solution, the first thing we did was focusing on the ease of getting data ingested into Elastic from different log source types. And as a result of that, we created a common schema specification called ECS that has been released as Apache 2 open source. And that's what Corelight and other companies have also adopted in building the integration. So since then, we built a lot of integrations with different log source types. Some of these integrations have been built directly by Elastics, other by the community and adopted by Elastic and supported by Elastics. In some cases, like with Corelight, we've been collaborating on building the integration to make sure that ECS had all the fields that were required for the specific use case, which is ingesting network telemetry. Part of the solution at the beginning again was, simplify the ingest of data. We added to Kibana an application that was originally named Elastic SAM. So thinking about the SAM use case, now that we have Elastic Common Schema, data integrations for multiple log source types that allow you to get the data in, visualize the data, and also do investigations in an easy way. So you can see here, this is timeline, drag and drop. You can add nodes to different events that are tied to an investigation. We also added case management recently for the analyst. In order to allow for efficiencies, really, for organizations that want to stop threats at scale, you have to think about automation. So we're going to talk a lot more about automation in the later part of this webinar. And with automation also comes the need of creating and knowing what you should be looking for when it comes to automated detection rules that let you know when there is some activity going on that you should be aware of. So we started releasing, first of all, we released a new component called Detection Engine that is part of the Elastic Security app. That includes a lot of out-of-the-box content in the form of out-of-the-box detections that are signature-based and also machine learning jobs that tie to different use cases going from network to host. Finally, arm every analyst. So since the very beginning, when we started working on Elastic Security, I've been thinking about the workflow for investigations. How can we make every analyst very effective when doing investigations, even with minimal knowledge of the security domain, thinking about those junior analysts or new to Elastic Security? How can we make the UI very intuitive so an analyst can quickly learn how to do investigations? For example, all the detection rules that we release, many of those are tied to the MITRE ATT&CK TTPs. So it's easy even for the junior analyst to quickly see and understand why they should pay particular attention to specific alerts that are generated by Elastic Security and what to do next. Once we built the Elastic SAM app, our founder and CEO, Shai Ivano, had a vision in a way, and really learning about different players in the security space and observing all the different verticals in a way within the security space. You know that while you observe, why not protect? Why two different products, two different UIs, two different solutions for the SAM and endpoint security? So what we did last year, we joined forces with a company called Endgame, endpoint security vendor, and as a result of that, we started integrating endpoint security functionality directly into Elastic Security. That started with the release of Elastic Agent, single agent, single installer that you deploy once, and once it's deployed, you can manage integration centrally. You can configure an agent to ingest local Windows event logs or to listen for syslogs, maybe events that you ingest from Corelight. And also, while you do that, why not protect? Enable that Elastic Endpoint Security module of Elastic Agent that allows you to gain additional visibility from the kernel, directly from the kernel, about processes running, DLLs being loaded, and so on. And finally, centrally managed. So this is centrally managed. It's really the future when it comes to simplify data ingesting, replacing some of the functionality that you can get today using Beats or Logstash that are still used a lot, and there are use cases that requires those. That said, our vision with Elastic Agent is to have a single installer that will do both detection, data ingestion, sensor when it comes to telemetry generation from the kernel and protections. So we learned about Corelight and all the visibility that Corelight provides on network telemetry. How does Corelight integrate with Elastic Security? And James or Richard would like to spend a couple of minutes talking about what you did on your end to integrate with Elastic?
Sure. So on our GitHub page, we do have our Elastic ECS pipelines. You bring them into standard ingest pipelines. And what it allows you to do is the data flows into your Elastic stack, it gets rewritten into each ECS format. So as you can see here, we have two different logs. One would be a con log, and one would be a SSH log. So in the SSH log, I could tell you real quickly that I see an SSH connection, and then you see the highlighted KS, I'm just telling you that somebody's sitting at the keyboard and actually typing in commands into your server. From there, we're seeing the standard servers that are being used, the software from the server and the software from the client, the source and address of this, so I can very easily with ECS go, okay, who's making an SSH connection, tie it back into the endpoint agent to figure out what's going on. And then the con logs, we're going to see all this interesting data too. So we're enhancing the data. We're putting in what's your AS number, where part of North America are they in, where's the geolocation. All this data is going to come right in with the Elastic pipeline. So it just ports right into the Elastic SIM. If you click once, and then what you could see next one is the Suricata logs. And the Suricata logs, Corelight Suricata logs, show you again the rule name that's being hit, the source and IP address. But now the interesting question is with this rule is I see someone made a connection to my system. Here's their source IP address, and I know it's got a poor reputation. But what happened? So inside this log itself, we actually have the Corelight unique identifier. And with that, I can easily pivot right into the con logs and actually determine what kind of connection it was. Was it just a ping? Was it a TCP handshake that was not established? And so it allows me to very easily determine, is this a serious threat or is this just kind of a scanning attempt? Next slide, please. And these are the Corelight dashboards based off of our ECS data. So again, they're available in GitHub. You download a file, import it into your saved objects, and these will appear. We're constantly taking feedback. So if you have feedback, please let us know. We're adding new things to it based off of feedback at all the times. So again, it's available on GitHub. Problems, you can just open issues or email us directly.
Thank you, Richard.
I'll hand it back.
So we just learned from Richard, native integration between Corelight and Elastic, data flowing from Corelight into Elastic using ECS. And when you think about ECS, it's not just a schema designed for network traffic, it's designed for any type of data. So it allows you to quickly do correlation once you have the data in Elastic across different log source types. You can see here some of these visualizations that you may have seen before in Kibana. These are specifically designed for Corelight. And Elastic Security add an additional layer on the top of these. First of all, you have the capability of having new workflows designed for investigations. But on top of that, tying back to the title of this webinar, driving SOC efficiency, you need automation. You cannot think about having eyes on glass at 24/7 and trying to find everything that you should know about, right? That you want to know about when it comes from your security posture. So it's important to leverage automation, and we do have a new component, a brand new component part of Elastic Security called Detection Engine that allows you to do just that. So different types of detections that you can enable. You can see here some of the rules that come out of the box. I mentioned earlier, many of these are mapped to MITRE ATT&CK TTPs. So in the latest release, we have 200 or so rules. 100 or so more are scheduled to be released in the next, with the next minor release. Some of these detection rules are query-based. When we talk about query-based, we have two different types of queries, and I'll touch on the differences, KQL and EQL, that can be used. We do have threshold-based rules and machine learning-based rules. And all the rules that we ship with the detection engine are in an open repository. So a lot of what I've discussed today is part of the open and free tier of Elastic Security. We do have a free tier, and anyone can contribute from the community. So we made it very easy from community contributors to upload their own rules that we evaluate, we test on the Elastic side, and then we ship with the product. So starting with query-based rules. So I mentioned KQL detection. So those of you that have used Kibana in the past are probably very familiar with KQL. That stands for Kibana Query Language. And this is a sample query in KQL. That's the use case. Corelight detects a Windows executable being transferred over the network without that .exe extension. So this is the query that you will use to search for those events. And again, leveraging telemetry that you get from Corelight. Anything that you can search can be added as a detection rule. So you can create a rule, whether that comes already out of the box, or you can create your own. You basically create a rule, you give it a name and say, this is the query, this is the index pattern where you can find that Corelight data that is relevant for these. Let me know when this happens. Send me a notification, Slack message, PagerDuty, or perform an action through webhook. So that's what you can do with a simple rule. And you can see here you're looking at two different data sets, files and files underscore read. Richard, would you mind elaborating a little bit on the difference between those two and why that's relevant for Corelight customers?
Sure. So with Corelight, you have the ability to actually send reduce logs. And what that really is there is a set specific where we don't send all the logs. We will send a very reduced set that maintains the high fidelity that you're used to seeing. So in the use case of like DNS, if you're opening up a connection, you're making lots of DNS lookups to the same host or domain, you might not get every DNS query. What you'll get is a subset of those DNS queries that shows what's happening, but does not take up as much space or send as many log entries in. And the same thing happens with our con logs, where if I'm opening up 12 connections to the same server, I might not see every one of them. I will give you a list, so you still know that connections happen to that server, but without seeing all the added connections. This is something you can enable or disable. It's really useful in very large environments.
Thank you, Richard. So these type of rules, KQL based, are great for single events that you want to be aware of. So again, search results, documents that match an exact query. That can be as simple as a Suricata alert that you get from Corelight. You know, when you receive a specific type of alert, maybe with some additional parameters that are included in that alert, let me know. I want to do an escalation when that happens because I want this to be investigated. KQL-based rules are great, but they're missing an important capability. And that's the capability of looking at sequences of events. So that's what EQL provides. EQL is a new query language that stands for Event Query Language. Query language that was developed by Endgame, the endpoint security company that Elastic joined forces with, and that we baked into Elasticsearch. So that's already available natively inside Elasticsearch as an additional query language. In the next minor release of Elastic, we're going to expose that to the detection engine, meaning that you'll be able to create detection rules or enable detection rules that will ship with the product that are based on EQL. So this is a scenario that requires looking at two different events in a sequence. So it's looking at a Suricata alert, looking at a connection attempt with an IP with poor reputation, followed by a connection that wasn't blocked by a firewall. So in this specific example, we're looking at two different documents, two different logs that originates from Corelight. This is not limited to that though. You can look at host-based events that may be followed by a network-based event that is detected by Corelight or vice versa. So that's what EQL allows you to do. So that will become available in the next minor as part of the detection engine. KQL, EQL, signature-based rules, condition-based rules, scenario-based rules, different names on referring to those are great for the known bad. Activity that you already know is bad and you want to be aware of. That's not it though. The attackers, adversaries, they're always looking for new ways to get into your network. And there is always the case of compromised user accounts, malicious insiders that already have access. How do you detect if someone or something, an entity, is suddenly behaving differently than what was seen in the past? And that's where Elastic Machine Learning comes into play. So Elastic Machine Learning is part of Elasticsearch. So it's not a separate product, not an acquisition that we did that is based on a different technology. Inside Elasticsearch, designed to operationalize and simplify data science. So that's really designed to be used by any domain expert without the need of having a PhD in data science. Machine learning, the way at a high level, without getting into specifics, it's learning from data that you ingest into Elasticsearch or that you already have in Elasticsearch without the need of any data duplication. You enable an out-of-the-box machine learning job or you create your own. You specify the input of the machine learning job. This is the data that I want you to model. And the output of that machine learning job is, first of all, a model. So you're not going to see it. You're not going to see it. You're not going to expose it. But think of it as machine learning having an understanding of what to expect. And you can also use that to do predictions. If you want to say, oh, what should I expect on a Tuesday at 10 p.m. when it comes to the average log rate that we get from a specific device. The model will be able to predict that. So in addition of building a model, machine learning will also keep evolving that model, keep learning from the data that is indexed into Elasticsearch, and let you know whenever there is an anomaly. Anomaly is a deviation from what machine learning model for a specific, part of a specific job would have expected for a specific entity, specific user, specific IP at a specific point of time. So I just touched on these anomalies. Another important component of machine learning when it comes to the output are the influencers. So when you create a machine learning job, you can specify the input, and you can also specify data elements that you will typically blame for anomalies in a specific use case. And influencers, typically are, for example, the host name or the username or destination IP, domain name, are typically what you will blame or look for whenever you know that there has been an anomaly for a specific job. And that's not necessarily part of the same data set. Again, it's all Elastic Common Schema. With Elastic Security, it doesn't matter where the logs come from. You can do correlation across all different log source types. A simple example of a machine learning job that is easy to visualize, that's why we chose to use this to describe how machine learning works, is looking at DNS logs that are generated by Corelight, and specifically looking at an unusual rate of an NX domain, non-existent domain DNS responses. So you may get this whenever you have, for example, an implant that is trying to reach out to what used to be a command and control endpoint that is no longer available. So you get back a lot of those NX domain status codes from DNS server. What machine learning does is learn from the typical. If you look at the bottom here, you see this typical. That's the average number of NX domains responses inside of a bucket of time, and that's customizable. So machine learning, and that's adjusted for seasonality. So what's normal in the middle of the day is not normal in the middle of the night, and vice versa. So that's adjusted for seasonality as well. And in this specific case, we had a spike, high count of NX domains responses. You see, we got 2,800, 2,870 in a bucket for the same destination IP versus the typical that machine learning would have expected, that the model would have expected in that specific moment of time. That's why you see that the severity is pretty high. So this is an example of a type of output that you may get. So you don't see any statistical terms or probability terms. If you drill a little bit into it, we expose part of that, but the idea is really to show to the security domain expert, this happened, it wasn't normal, you may want to look into it, without really exposing too much complexity that is data science specific. Another common use case with machine learning is DNS exfiltration. So DNS exfiltration is a technique used by adversaries for command and control and to exfiltrate data over DNS. And if you look at the domains that the DNS queries that you see here at the bottom, you see that the subdomain part of this query looks a lot like base64 encoded text. So that's how you can get data out. And DNS typically is not blocked. And that's an easy way for adversaries to establish command and control, or to establish to exfiltrate data out of your network without being code. And this type of technique is, if you think about those query-based KQL, EQL-based rules, are quite hard, or basically it will be impossible to create a detection rule that will detect it. Because what are you looking for? You could think about looking at the length of the subdomain, and you may also assume that your adversaries will find out that the rules that ship with the product include a specific length and try to stay below that length. So it's hard to kind of stay on the top of that. What machine learning does in this specific case, the job is looking at the information content of the subdomain. So it's really learning from the typical queries, what's the average information content? And if you see that we get a value that is much higher, in this case, it's more than 100 times higher, then machine learning will generate an anomaly, and we'll let you know about it. So just to describe at a high level how machine learning works. So there are many other machine learning based use cases where anomaly detection comes into play. And many of these, the first few that I've listed here, they're really looking at a specific unusual rate of events, unusual rate of queries, really modeling your data. And what you can do also with machine learning is not only look at a single source of data like Corelight, but you can also look at correlating data that you get from different log sources and think about those influencers. So you can learn about anomalies from network data and see if there is any type of other activity or that you can blame for it. So you can look at anomalies that are tied to user logout activities, for example, remote access data, again, data exfiltration, anomalies tied to outbound data transfer sizes. You can learn from Corelight, what's the average transfer size that we see? Are we suddenly see a spike from an unusual user? And so on. So these are just some of the examples. We do ship a few out-of-the-box jobs with Elastic Security. Again, they're all based on ECS. So regardless how you get that telemetry, regardless whether you use, for example, Elastic Endpoint Security or you have another endpoint security solution, once the data is normalized into ECS, you can leverage out-of-the-box content that we provide. And of course, leverage the telemetry and visibility that you get from Corelight on your network. So we do have a few questions.
We have a few questions. Yeah, we have a few questions in the chat area. The first is a question for Corelight is, does Corelight support GCP as a cloud provider? And yes, we actually do. In that case, we actually use our software sensor and Gloop in GCP to go through. The second question, Mateos, for you is, sounds like Elastic Cloud could have a UEBA solution on their hands. Everybody else is doing it.
Yeah. So machine learning, as you can see from the examples here, I haven't used the term UEBA, but what machine learning allows you to do is modeling entity behavior. Whether entities are user or machines, you can do that, model an application behavior. So it's very flexible and customizable, and is used a lot for UEBA type of use cases when it comes to modeling users' behavior as well.
Okay, excellent. And then there's another question towards Elastic is, will or does Elastic Security have any anomaly, ML detections around beaconing?
Around beaconing, you not out of the box, but that's an easy rule to create for beaconing. So I've seen customers do that before. So that's easily done.
Excellent. And I think that's actually a great point also to mention is, Corelight is continuing to evolve and develop content, and we're going to be producing content around some of these ML-based use cases that then you could use within Elastic Security to really kind of hone in on to understand. So I would be on the lookout for great new content coming from Corelight over the next few months. Matteo, are there any other points that you want to make while we see if anyone has any follow-on questions?
Just generally speaking, if you want to try out Elastic Security, Elastic Cloud is our SaaS. You can sign up for a free trial. You can you have 14 days of free access to Elastic and Elastic Security and all the other solutions. We have lots of content on our website when it comes to past webinars, blog posts, and again, a great opportunity is next week, ElasticOn conference. If you cannot attend live, you'll have access to all the recordings of the sessions. You'll be able to engage with us during ElasticOn. So we're going to have some panels, roundtable sessions. You can use the chat features during sessions if you have questions. So if you want to learn about specifics about our roadmap from our product team, for example, that's a great venue for that. So I'm looking forward to talk to many of you in that venue.
Excellent, excellent. Richard, is there anything that you'd like to mention?
Just if there's any feedback on our Elastic ECS pipelines, our dashboards, please either let me know or put them in our put a comment in the GitHub, and we will work on adding any new content requested.
Excellent. Excellent. Well, I don't believe I have any closing remarks. I think Matteo and Richard did an outstanding job kind of hitting all the high notes for this. I'll pass it back to you, Ed.
Excellent, thanks, James. And we'll go ahead and wrap up today's session. So I'd like to thank everyone for joining us today, and as well as our presenters for sharing their expertise with us. And we'll go ahead and wrap it up. So thanks again for attending, and have a great day.
Thank you.
Thanks, everyone.